Okay, I just want us to look at this equation following up after this one. All right, so we have 2x squared minus 50x is equal to 0. So once again, this type of equation that we have here is quadratic in nature, but what we observe is that this equation should firstly, like we said, should be in the form of ax squared plus bx plus c. It should be in standard form, so it is already. And then what we note first and foremost is that, can we factorize this expression on the left? Yes, we can. And we can factorize it by actually taking out the highest common factor, because whenever we consider factorization, the first thing we gravitate towards is, can we take out the highest common factor? Now, what you can see here is that the highest common factor is actually what? It is positive 2, but it is also accompanied by an x, because we take out the common factor that has the lowest exponent. So our highest common factor here is actually 2x. Now, since this highest common factor is not it's not a numerical value alone, it is actually a coefficient of 2, which is a numerical value accompanied by a variable. We cannot do what we had done here previously, which is divide each term by the highest common factor. Why? Because it has a variable, right? And we avoid doing that, because if we divide each term by 2x with the variable there, what happens is that we actually lose a answer. We lose a solution from the equation. So we don't want to lose a solution. We want to have all of our solutions available that can actually satisfy this equation. So we don't divide by 2x, rather we take out 2x as a highest common factor, which is very important. Then what is left after we take out 2x? For our first term, we are left with x. For our second term, what are we left with? For our second term, we are left with 25. All right. Now you can see that we have now a product. We have the factor 2x and we have the factor x minus 25. So that means now we can go ahead and apply the what? The zero factor law. Why? Because no further factorization can be done, 1. And then 2, you can see that the two product of factors are equated to 0. So that means we can apply the zero factor law. So 2x is equal to 0, or x minus 25 is equal to 0. Then we solve each independent linear equation separately. So 2x is equal to 0. We know that 2x is equal to 0. We divide both sides by the coefficient of x so that we can isolate x, so x is equal to 0. Or x minus 25, x is equal to 25. We simply transpose the negative 25. We get x is equal to 25. And that's that. So guys, this is really nice and, simple. I mean, really and truly, this way we ensure that we do not lose any of our solutions, right? So what's important here is that whenever we have an equation and we can see that the highest common factor is a numerical value, it's actually a constant value, we can go ahead and apply the division of that particular highest common factor for each term, so that we can have the simplified quadratic form of the equation, x squared minus 25, and then we can proceed with the relevant or required factorization, apply the zero factor law, and then get our roots. But whenever we can see that the highest common factor is a variable that we are taking out, it has a variable in it, then we cannot divide each term by the what? By that highest common factor. Why? Because it has a variable. And if we do that, we would eliminate one of our solutions, and we don't want to do that. This x squared implies that we should minimally have two solutions. Oh, sorry, we should have at least two solutions. Okay, but yeah, so therefore we can see that x is equal to 0, x is equal to 25 are the two solutions of x, the roots, which will satisfy this equation.